Hangout, where today we have new observations to show you from the Hubble Space Telescope of the comet ISON. And today we have a panel of astronomers and people members of the Hubble Heritage Team who put together the latest images, and we're going to show them to you and talk to you about them today. But before I do that, I have to say I need to let you guys know that we are encouraging you to comment and ask us questions on all kinds of different places. We're looking at the Hubble site, the Hubble Space Telescope Facebook page. We are also following the hashtag Hubble Hangout on Twitter. I have that up in a column right here. I'm looking at it now. And we're also monitoring comments on YouTube and the G+ event page from which we are broadcasting. So I would encourage you all to start interacting with everybody on our channel there. Sorry, I just heard some background something. So with me today, as always, are my cohorts, Alberto Conti, the James Webb Space Telescope Innovation Scientist, and Scott Lewis. Hi guys, welcome to.
Hey Tony, how's it going?
I'm doing great. How you doing, Alberto?
I'm doing very well. How are you, Tony?
Are you there? Wake up! Wake up!
It's a happy day.
I'm here.
It's a very happy day.
Okay.
NASA's back.
So
yeah.
Yes, that's the big news of the day, guys, right? I mean, NASA's back. NASA is, the government is now open, and we have our beloved space agency back. So our friends and colleagues are back to work, which is great news. And projects can continue, missions can go on, telescopes can get built now that they're back up. So we're very happy about that. And Alberto, we also have some good news on your front, don't we?
I don't know if it's good for me. Yes.
Yeah.
so yeah.
Go ahead. Tell us what's new with you.
Well, I will be leaving Space Telescope at the end of the month to take up a job at Northrop Grumman as the innovation manager for their civil air and space sector. So it's a great opportunity I'm taking up. I'm very, very sad though to leave Space Telescope, and I just want everybody to know that it was not a very easy decision, but.
Yeah, I know. I remember when you were agonizing over it when you were when they first made you the offer. So I just want to congratulate you, and I know that and wish you all the best. We are going to miss you here, that's for sure.
I'll keep an eye on him for you. So he's moving to my neck of the woods, so I'll keep an eye on him.
That's right. He's moving out to California to be with Scott. Right. He's leaving the East Coast. But wait a minute now, though. You're not just leaving entirely, right? You're going to be able to still do these hangouts with me, right?
Absolutely. I'm going to still keep doing hangouts with you as Northrop Grumman. I'll see you at the AAS, for example. I'll be there, and part of my portfolio will be JWST, so I'll still be involved with Space Telescope very often. I will even come to Space Telescope in the East Coast rather often. So I'm not really leaving. I'm just going to keep bugging you.
That's right. So don't worry, Hubble Huggers. We're still going to be able to have Alberto here with us, and we're going to be doing hangouts together. Scott laughs every time I say that. I like that term, so we're just going to keep
all for you. That's all you.
Okay. So let me introduce the people who have brought us the latest observations of Comet ISON. We have astronomers and people who've dealt with the data that Hubble has taken, and I guess it was just last week Hubble made the observations, and the data are now available for everybody to download. So with me is Zolt Levay. Hi, Zolt.
Hi, Tony. Hi, everybody.
Hi. Yeah, he's a member of the Hubble Heritage Team, and he's made some of the great images we're going to be looking at. Also with us is Max Muchler. How you doing, Max?
Hey Tony, always great to do these with you.
Yeah, we've got a lot of cool stuff to talk about today, and the an OPRO astronomer, outreach astronomer, Bonnie Meinke. Hi, Bonnie.
Hello.
She's here to provide us with expertise on comets and the background and help us interpret these images. As is Jianyang Li from the Planetary Science Institute. Hi, Jianyang.
Hello, everyone.
Hi, it's good to have you back. Thanks for joining us. Okay, so let's talk about the image. First of all, Zolt, do you have some handy that we can take a look at here?
I have an image handy. Let me go ahead
I knew somehow that you might.
I know.
Let me go ahead and share my screen.
So while he's doing that, Max, these images were taken when exactly?
That was last week, kind of in the middle of the night, October 8th, October 9th, right in there. And it was kind of funny because a lot of us were at a meeting in Denver, Jianyang Li and myself and a number of other people who are using Hubble to study ISON. So, you know, that's just a reality in science, is that most of your collaborators are elsewhere, and often you're working together from a great distance. So it was actually pretty cool to actually all be in the same hotel. You know, so new data was coming down.
So you guys are watching it as they're coming down and processing it as quickly as you can, right?
Yeah, getting our first quick look, and it was quite fun to actually be together to experience that, which is actually, it might be surprising to your audience to realize how rare that is.
Yeah.
Did you have bets on how it was going to look like?
No bets, really. I think we, you know, I would say we weren't too surprised. You know, obviously, I think we're getting to, you know, the fact that there was some speculation about what we were going to see.
Right.
But we weren't the ones doing that speculating. I think none of us were too surprised with what we saw.
Okay, Zolt, so here you have it up now. This is the press release image, right? The one that we put out today?
This is the press release image that we put out today. So this is a color composite. It's a composite of 2 observations in 2 filters, a blue filter and a red filter or infrared filter. And it shows a little bit of color. It's kind of the color that we would expect. I think maybe other people can expand on that a little bit. You notice there's no stars in it. The stars have been removed. They're moving during the exposures and between the exposures, and Max's we'll talk about that, I think, a little bit. The processing, we've talked about that before, that in this way we process the images, the stars are removed. And so there you have it. I guess the news from the image, the first thing you notice is that the nucleus is still a nucleus. And there was some reports that some evidence that the comet may have broken up, but it looks like from our image, at least at the resolution that we have, which is the best available, the comet is still intact. The nucleus is still intact. The tail is much bigger than it was before, and it looks like a comet.
Do we have a sense of the exposure times on these images?
What were the times,
well,
Max? They were tens of minutes.
Yeah, and 2 filters. Well, for the 775 filter, it was 348 seconds, and I think we got something more like times 2, and then something more like 500 seconds for the B filter times 2. So that's the total amount of exposure time we had.
Okay. So Bonnie, do you have any comments on this? What does this tell you? What do you think about what Hubble's seeing? You're muted, I think.
Muted, yeah.
Oh, I'm muted. Okay. I think what we're seeing here is something that's not too unexpected, and I think it's funny that with all the hoopla over this whole thing, that it turns out to be just coasting along, fizzing along, and
just being a comet, being its comet self.
Being itself, and so it's overhyped, it's underhyped. People can't make up their minds about what they want it to be, and just let it be what it is.
It's awesome. That's just all it is. It's awesome.
Yeah, it's awesome. It's a comet. It's going to be cool no matter what.
Let it be a comet, people. John Yang, what about? Do you have any comments on this? Did you have any expectations prior to these images of what the comet might be like?
Well, not much expectation. Although I did hope that the comet is behaving, but you know, from the images we see that it's still a very nice comet, and as Zolt said, it's much bigger now. And I want to point out one thing. If you compare this image, if you still remember what the April image looks like, the direction of the tail actually changed.
Oh, Zolt, you have an image that kind of illustrates that, don't you?
I do. Here's the comparison. Now, this on the right is the current October image. On the left is an image from the May observations. And these are as close as I could get it. These are intensity scaled equivalently and spatially scaled equivalently. So they should be a pretty much apples to apples comparison. The only difference really is that they're taken with 2 different filters.
Right. And I think in the 2 images you show here, they are displayed in different orientations. But if you rotate them both to north up, like the same sky orientation, you'll notice that the direction of the tail actually flipped. That's because the Earth is now on the other side of the Sun compared to.
Right.
Oh, that's interesting.
Yeah.
So wait, say that. So I see what you're saying. You're saying the tail is flipped to the other side.
That's right.
Okay. Yeah, I think what this really illustrates well is just the change in the brightness and size, apparent size, because everything else is the same, right, Zolt?
Yeah, it should be as close as I could get to being the same.
Okay.
So do we have an idea how long the tail is right now?
Oh, wow.
It's hard to say where it ends.
Yeah,
It's a
some of the
KCCD. So I think 1 pixel is like five kilometers.
55 kilometers.
Yeah. So we can do a quick.
I have a
one pixel is 55 kilometers. Count the number of pixels across there, and you get a sense of how big it is.
All right, I'm gonna go count.
An exercise for the student.
I can give you a little idea about that, although it's not related to the tail. It's related to the nucleus. That here's an image that's zoomed way in on the nucleus, and I wanted to give an idea of cool. Emphasize the fact that we don't see the nucleus breaking. Whoops. Where'd that image come from?
Oh,
Zolt. No, he has images and so they just randomly pop up on his screen. Because
I don't know what happened, but anyway.
That's a cool
awesome.
comment.
So I wanted to show that as far as we can tell, the nucleus is still intact. So this is zoomed way up. As you can see, the bar is 100 pixels long, which is 4 arc seconds in this camera. And at the distance of the comet, that's 5,500 kilometers is the bar. So that's a 100 pixel long bar. So each pixel is 55 kilometers.
I also see Max as an image, actually, a different color scale, I think, right, Max?
Yeah, I was just looking at the actual data where you can see it's sitting on the camera, and just for reference, this is the wide field camera 3, which is roughly 4,000 by 4,000 pixels, and you can see that the tail clearly goes off the edge of the chip here. So even just the tail that you can see here would be 4,000 times 55 kilometers would be over 200,000 kilometers that you see just here. And of course, the tail goes off the edge, and we know from other ground-based images that the tail is quite long and it tapers off. So it's a little difficult to say where the tail ends, but certainly just in the image, what you're seeing here in the Hubble image is on the order of, I guess, 200,000 kilometers.
I see. So, but actually, these images are very telling because I think there were a lot of speculation about exactly how the comet would emerge after perihelion, and so it looks like the nucleus is pretty compact. So what does that tell us about the composition of the comet?
Well, it's obviously not as the loose rubble pile, that maybe some people thought, that it's just ready to fall apart even before it encounters the sun. And of course, this is what Hubble can do best: is examine the nucleus up close with high sensitivity and high resolution. And if anything were falling off of there, if it was crumbling or disintegrating at all, we would definitely see it clearly. We've done this before with Hubble, witnessed this, and so obviously we're not seeing that. And so it does seem to say something about, the integrity of the nucleus, that it's not maybe as fragile as some people had thought. It's certainly not beginning to fall apart. Doesn't really say much about what's going to happen next. There's been some good analysis about, the likelihood that it will now survive its close encounter with the sun, but I think we'll just have to wait and see.
So I think the real takeaway here then is that we still see the comet relatively intact, and that it is still, it is getting brighter as one would expect. I think some of there was a lot of unknowns going into this. So we didn't know for sure if the comet was, how loosely packed, like we said, whether it was going to break up, or even if it was going to survive perihelion. And I think now, and Bonnie and Jianying, you can comment on this if you want to. I think that's not expected to happen now, correct? In other words, break up as it goes around the sun. It's supposed to stay intact, correct?
Well,
right. Go ahead, John.
Oh, well, I would say that it doesn't happen now, but the possibility will still exists as it moves closer to the sun, especially when it's nearest to the sun. That's where the heat, the heat is the strongest and the gravity is strongest. So
okay.
It's still hard to predict what happened. But I have a colleague, Matthew Knight and Kevin Walsh. They did some very nice studies, very detailed studies about the possibility of for this comet to break up during the perihelion passage. And their result is that the possibility is small. So.
Okay, then that's so. I guess that this particular image or these particular observations won't conclusively say one way or the other. But there was something that was settled, Jean Yang, and I'd like you to comment on that and maybe show us your image that we had up earlier before we started the hangout. There was some speculation that there might be some jets or some sort of material coming off of the comet, and I think you've got some more information on that, correct?
That's right. Yeah, if you remember, in the April image, after we did some enhancement, we can clearly see a jet in the sunward direction, and from that, based on that jet, we actually determine where the spin pole of the comet was, so after the comet goes behind the sun for several months, now Hubble gets to take a look at it again, and then everybody is curious about whether the jet is still there and how does it look like. So we use these new images as shown on the screen now.
Yeah, this is what Max is showing now. I've got it up, so go ahead and feel free to describe it.
Yeah, thank you. So we did the same processing for the images, and then we look at the sunward direction, and then there's nothing there in this image. There's no jet in the sunward direction, and it doesn't say the jet is completely gone. It just says that we do not see this jet in the same direction as.
Okay. So you found that there's no jet, and this image is what you're using to explain why that is. What is this image we're looking at? Can you describe what it is?
Oh yes, yeah. So obviously the upper panel is the image that we started to work with, the original Hubble image. And then second image, we did the enhancement. The way we did the enhancement is that we assume a Comet model, which is like the average of all the comets, and then we subtract out that model. And that model we subtract out is symmetric with respect to the center. So if there's any asymmetry, like enhancement of a jet in the sunward direction, then it will show up clearly in this image.
Okay, so this is getting a little confusing. Let me make sure I get this right. So what Zolt is showing is the top one is an actual observation. The bottom panel is a model of a comet, and what Max is showing is the subtraction of those two. Correct?
Well, actually, this bottom panel is what Max showed.
Okay, so that's the same thing, but it looks different. So what Max is showing doesn't look at all like this bottom panel and what Zolt is showing.
I think it's a scale.
Maybe a different stretch.
Yeah.
Well, I'm showing the one from April.
Oh, I see.
He's showing the previous one.
It shows the jet.
Okay, so let's go back to what Zolt has then. So observations of the comet, and then what Jean Yang, what you did is you have this comet model that you've built on a computer, and then you've just subtracted these two out, and whatever was left, because there's no jets in the model, and so if there were going to be a jet in the comet, it would show up in the ratioed image, right?
Exactly. Yes.
Okay. All right. Just want to make sure people understood what it was we were looking at.
Yeah.
So that's how you know that there weren't any jets in the comet.
Yes.
As was speculated before. Good.
Yep.
Okay.
Yep.
Awesome. Okay. So Bonnie, sorry, I'm getting myself distracted here. So this comet so far been going along just fine. Not a whole lot of surprises here. Do you have any? Was there anything about the Hubble observations that you found particularly surprising or interesting about what's happening with the comet now?
Well, I think that the most interesting thing is that we don't see that jet anymore, and that being able to see this jet depends a lot on careful modeling. And I think that we need to go back to that for just a second, just to mention what a model really is.
Yeah, I'd like to talk. That's a good point. Let's talk about that a little bit.
Because I think a lot of people think of model, they might think of, like, a toy model.
They would think Tony or me.
A fashion model. Yeah, exactly.
Really attractive people. Yeah.
Yeah.
Oh, thanks for that.
Okay. Yeah.
But this sort of coma model is actually a mathematical model. So it's something that's done on a computer. It's based on the idea that gas would be coming out in all directions from a nucleus, and then you subtract what that would look like from the actual image, and you get what's left over. And so that's what's happening between the top panel and the bottom panel here.
Yes, and so what makes this valuable, though, is how good you are in making your model to begin with, right? So how sure are we that these models are an accurate representation of the comet that we're trying to model? What are they based on?
Jianyang?
Jianyang, I'll put that to you. What are these models based on?
Right. Well, this model is actually is based on our basic understanding of how comet works. As Bonnie said, we assume that the dust and gas are coming out from everywhere on the nucleus and towards all the directions. And the important thing is that in this model we do not build in any jet. So when we compare this model with the image, if there's any jet in the actual image, then we can see it. That's the point.
I know, but what bothers me about this a little bit is that, jets can appear virtually anywhere within the nucleus itself. And I don't know how you say to a model, here, have a jet, and have it be in a spot that you can be sure of where the model would be in the actual observation. I mean, where the jet would be in the actual observation. So I'm curious as to how that works. I mean, you can type into your computer, make a model of Comet ISON with the jet, and it'll go out and do that. And then, but how can you be sure that where the jet appears in the model is going to be anything like where it'll appear in an actual observation had Comet ISON had a jet?
No, we actually did not do the jet in the model. We assumed that in the model we did not put any jet.
I know, but that suggests that there is a model out there where you can put a jet in.
Oh well, right? Yeah. If you have the images, where the jet is, then you can try to put a model in the jet and try to with this model you can understand what the jet is like and how the jet
Let me ask Tony's question in a different way, I guess. So I'm assuming, I don't know this, but I'm assuming that the models, for example, take into account the composition of the possible composition of the comet and the radiation from the sun and the possibility that indeed there is a jet. So is that the case, or the model is very different?
Well, the model is actually a very simple model. It just assumes that everything released from the nucleus move away from the nucleus at a constant speed and in the same behavior towards all the directions. So in this case, we will have a symmetric coma.
Okay, I think I understand what. So this is in this model you've put everything in there that you know about comets, and made it the simplest possible case. So by subtracting out the model, you've subtracted out all the things that you know are part of the comet, and anything that remains would be any anomalies, any strange things that you wouldn't ordinarily expect to see. So I get that now. So I guess there isn't really a need to put in a jet, just to sort of see that there is one, and compare it with that. So I understand a little bit better now. Thank you. Okay, I'm seeing a lot of images fly by over there on your computer, Max. What are you doing? Anything we should be knowing about?
I'm just trying to some extent, I was just
working.
Yeah, what is he doing? He's just working, just showing us our screen. Stop working, Max.
Yeah, could you leave me alone? I'm trying to get some work.
Yeah.
Sorry to bother you, but we're all watching you work. So.
Well, I was just trying to illustrate a little bit what Jianyang was talking about. So right now I'm showing like the image, my attempt to make the cleanest image that I could make to get rid of, in previous Hangouts we talked, I'll back up a little bit here to show some of the messy images with cosmic rays and star trails. And so it was my job to kind of make the cleanest image I could from all the input images. And that's what I gave to Jianyang Li, and he applied his model. So I'm just sort of blinking back and forth between my clean image and then where his model has been applied. So I was just sort of showing the difference there of his, once he subtracts his model, and it just allows us to reveal what's going on, especially in close to the nucleus.
So which is which? What's that?
This is Jianyang Li's model subtracted version of my clean image, and this is my clean image. So I'm just toggling back and forth.
Okay.
And you can see how much more you can see. Once John Yang has done his processing, you can really see in towards the nucleus much more clearly, and in particular that there is no sunward jet there like we saw so clearly in his earlier observation back in April.
Okay, I'm glad this is a good time to talk about one of the things that we had mentioned earlier. I think in one of our meetings. Go back to the other image, the one you just had up. The one with the star trails in it a little bit. This one. So there's a lot of stuff in here, and we're gonna let people are going to be downloading Hubble data. They're going to presumably see some of these things. Let's identify what these are now, and so that we can get all the questions answered and all the conspiracies dealt with up front. Okay?
So anyone watching the Hangout on Google Plus, I did post that image there live. So if you want to see full quality of it, you can go into the Hangout event as well.
Awesome. Thank you, Scott. Okay, so we're seeing a lot of stuff here. Why don't you explain all these things? What are all these the streaks and the spikes and everything else?
Yeah, so for this one filter, this is the F775W filter. We only got 2 exposures in each filter. So what I'm doing right now is just toggling back and forth between those 2 exposures. So you get a sense of a couple things. You certainly see the comet, but you also notice star trails. Those are those parallel lines. You get a real sense of motion here that we're tracking a moving object because those streaks you see, those parallel streaks, are stars in the background. And of course, if we're tracking the comet and we take a couple 100-second exposure, the stars become streaks. And then you also see a random assortment of cosmic rays in each image, but of course it's different cosmic rays in each image. And you also notice some things about the camera. The camera has 2 chips, so that's why there's that dark streak running through the middle of it. But you might also notice that dark streak shifts a little bit. We do that intentionally. That's called dithering, such that when we combine the exposures. So now I'm going to display just a simple combination of those exposures, and you see that the gaps don't overlap. So the images sort of fill in each other's gaps, and you really see all the star streaks and all the cosmic rays together here.
And you can also see the difference in angle of the star trails as well from the different exposures. So as Hubble followed the comet, those stars, which were points, got smeared across the CCD. So
that's right. So then we have software to combine the images in a way that actually cleans out all those artifacts. And so after doing that, just here's sort of a before and after. And you can see that because we only took 2 exposures, we can't actually reject the artifacts that are in the gaps there that run at that diagonal there running through the image. So I do apply another step. 2 images is not great. We like to get 3 or 4 or even 5 to really clean up an image. In this case, we only had 1 Hubble orbit to work with, and we're trying to get 2 filters. So we could only get 2 exposures. So you'll see that even when I've cleaned up the image, there's still a fair amount of residual cosmic rays, and even you can still see a hint of the star trails. So it's tough to clean it all up. I did apply a next step here where you can see I'm just toggling now. That kind of gets those residuals, which we know are just cosmic rays. Again, you might look at this and say, hey, isn't the comet breaking up? Look at all those little particles. But no, we know that those are just residual cosmic rays that we could not clean out. And so here's, again, back to the clean image after I've applied everything I can. Now, I'm going to do something a little funny. In DS9, of course, we can use any color lookup table. I happen to be using a blue one here because it just helps my eye see things.
DS9 is the viewer he's using, folks. That's what that is.
That's right, for displaying FITS data. Not looking at a JPEG image here. This is the actual FITS data. And I'm just going to switch to a rather psychedelic one just because it kind of emphasizes even further some of these artifacts. So this is the cleanest image that I could generate. And when I switch to this kind of psychedelic, for one thing, you can kind of see the extent of the tail running off of the chip. But you can still see hints of those residual cosmic rays and star trails sitting there. So again, that's not something to get too excited about. They're kind of running all throughout here. We understand them. They're just star trails and bright cosmic rays. And then, of course, the noisiness of this chip gap that runs through at a diagonal. And I'll just switch back to the cool. This is called cool.
Those are not spaceships hiding behind the comet or
that's right.
anything
There's
like
just,
that.
We understand all these artifacts. There's nothing to see here, folks. Move along.
Please move along. Yes.
And then, of course, the last thing again is taking this clean image. John Yang was able to generate this model subtracted image, which he did very quickly at this meeting last week that we were at in Denver, and it was pretty cool. Within a few hours, he was able to realize that there was no jet there, and again, that's other than the fact that the comet is still intact, I would say maybe that's the most interesting and relevant result. You know, the fact that we don't see that jet that John Yang saw back in April.
So this is part of these artifacts, just to get onto that for just a little bit more. This is some of these things we're seeing are unique to the fact that Hubble is imaging something that's moving so quickly relative to the orbit it's in. And we don't always have this problem, do we? Or do we always have the problem of getting background stars subtracted out or completely removed from an extended foreground object?
Well, like I said, ideally we'd like to have more time so that we could take more exposures, and that would allow us to make the images cleaner. But we're trying to. We only have.
That's important. Why? Why are more images important?
Well, that gives us the leverage. Obviously, the more we can build up the images, there's more to compare against to reject artifacts, but also just to the kind of the graininess you see in the image is what we call noise. So when you only have a few short, relatively short exposures, you're going to have a lot of that kind of mottled noise look, and that's just noise in the detector. And we can't really. The only way to remedy that is more exposure time, more exposures where you just kind of keep building up the signal against all the noise in the background. And then, of course, when you enhance the image, you enhance not only the comet features, but you also enhance the noise and the artifacts. And so to some extent, you can see that in John Yang's model subtracting image here. You can see an enhancement of those star trails and also an enhancement of the chip gap there. So, if we had maybe 5 exposures instead of just 2, I would have been able to do a much better job of removing all that so that it wouldn't get enhanced by John Yang's modeling method.
Yeah, that's one of the cool things about astronomical imaging and with telescopes and CCDs is that you can take a whole bunch of short exposure images or shorter exposure images, move your telescope and CCD around, and then as you align those all up and add them together, the signal adds up as the number of images you've taken, but the noise only goes up as the square root of the number of taken. So you can get a lot more signal with less noise, and you also can find out from one individual image to the next what a cosmic ray is, because in one image you'll see a little streak like that, and it won't be there in any of the other images because they're randomly distributed. So you can find out you can identify them and get rid of them easier. And then when you add all that stuff up again, you get a really nice image. So we only had 2 apparently in this observation or in this orbit. So we're working with limited amounts of signal here.
That's right. And we could have used more orbits, but it made sense for us to try to just get what we can in one orbit and save that orbit, and we're planning other observations for a couple of weeks from now.
Okay, so that was a question mark, I thought. So there are going to be more Hubble observations of ISON?
Yeah, there's a number of programs executing. The Hubble Heritage team, we are planning another one this week to execute. We won't be able to observe the comet until beyond November 4th until it passes the sun and comes back out again. So there are a number of programs actually. Hubble Heritage is just one of them, but we are planning another single orbit, probably very similar to the one we're looking at, and there are several other programs doing imaging and spectroscopy in the same time frame. Okay,
thank you, Max. I want to move on to a comment that I just saw from Charles Bell, who goes, "Can you talk about the orbiting solar observatories that will likely capture images as ISON gets closer, and when and for how long?" And before we answer that question, Bonnie, I wonder can you make a comment on and tell us about sun-grazing comets, because ISON is a sun grazer, correct?
Right. It'll come very, very close to the sun.
Okay, so how close?
I think within 1 million miles of the surface of the sun. I don't remember the exact number, but very close.
How does it compare with other sun grazers, do you think? When it comes that close, do you have any sense of whether this will be, like, remember, I think it was Comet Lovejoy was one that went by, and I think the SOHO spacecraft saw that pretty well.
Yeah, so these sun grazer isn't a well-defined term, but it basically means coming really freaking close to the sun. And the cool thing about those is
everyone. Very
that
I know, I have to define that jargon.
Yeah, jargon, please.
Keep it professional here.
We lost souls, it looks like.
So it's going to come really close to the sun, and what that basically means is it's so close that the sun's magnetic field is able to grab on to parts of that comet. So it interacts, the gas that's coming off of it, the gas and dust, interacts with the sun's magnetic field. And when Comet Lovejoy did this, instead of following that beautiful, pretty arc that you would expect to see with any sort of astronomical object orbiting the sun, you see little like waves and puffy bits, and you can see some of the material get grabbed off by a magnetic field line. So these sorts of sun-grazing comets are actually fantastic free solar probes.
Yeah. So wait a minute. Does that mean that that there's some ions in the there's just charged particles in the comet itself that can react with magnetic fields?
Right.
Okay.
And you're getting so close to the sun that you're interacting with the particles coming off of the sun as well.
So Alberto's got some really good anim. Is that Lovejoy we're looking at, Alberto?
I don't actually. No, I don't think so. This is from SOHO. Okay. Actually, it's two comets that are sun-grazing. They come out the other side. But I thought it was actually they're quite spectacular. Because of the SOHO website, they have a tremendous amount of this. Either comets that plunge into the sun, or as Bonnie was saying, there are lots of the sun-grazing comets.
Yeah, I recognize the instrument too. That's LASCO C2's chronograph there. So. Right. Is in addition to that awesome CME that's going off there, there's also these two comets you can see flying by. So that's a sun grazer, and that's what ISON's going to be. I think we talked about this already, and we mentioned that it's probably not going. Well, the expectation is that it's probably not going to break up as it goes around. But who knows? It's hard to predict these kinds of things. So to get back to Charles Bell's question, the orbiting observatories, well, there's a ton of them now. Since SOHO's been up, there's a whole bunch more. We have there's the Solar Dynamics Observatory. They're up there. They're high resolution. They have all kinds of images on there. SDO's out there. We have Stereo. Stereo will probably catch a Stereo or two spacecraft that are at opposite sides of the sun, looking at different sides, so that we can get a full 3D view of the sun. SOHO is still out there taking data. Amazingly, it's been doing that since the 90s, I guess, right? That's been up there a really long time. So we expect that a lot of eyes will be on this comet as it goes around in the solar arena, and it should be pretty spectacular.
I'd also like to mention that Messenger is planning on looking at the comet as well.
What's Messenger?
Awesome.
Messenger's in orbit around Mercury.
Right. Okay.
So it's going to be closer to the sun when all of this happens. So it's a view from closer in.
That'll be great. When are they gonna do the observations? Do you know?
I'm looking at it right now. November 19th.
Awesome.
When they're scheduled.
Yeah.
And some of the sun ones, SOHO is scheduled for late November. Stereo is scheduled for late November. Those are the only ones I see right now. Oh, okay. No, SDO I don't have a date for. Sorry. I have a little thing on my wall that I've been keeping track of who's going to look at what.
That's really cool.
It's kind of exciting. Really, I've had to cross things off as time goes by because poor Brisson didn't make it. It was a balloon experiment that was going to look at the comet. It didn't make it. So
what happened there? What?
I don't know. They had some kind of malfunction. I don't know if it was a instrument malfunction or a larger craft malfunction. I don't know did they talk about this at the DPS? People who were at the DPS?
I don't recall hearing anything about that.
Okay.
Someone popped the balloon.
Someone popped it.
Was that
yes.
Oh,
some very mischievous person with a very long pin.
Right after they stole candy from babies and things like that. They pop their balloons.
Yes. So, okay, Zold, have we gone through all the images that you have? Or do you have anything else you'd like to show us?
I don't think I was, a couple of other things I have just are the constituent images that we use to put the color image together, if you want to see that.
Let's see those, absolutely.
Let me share my screen again here. Just takes me a while here, sorry. And I lost network connection for some unknown reason.
Yeah, we noticed you dropped away there.
Shucks. So.
Oh my gosh, there's 65 comments on YouTube. I have to look and see what's going on.
Well, I did put some of them in your Hangout window if you want to.
Oh, you did?
Those.
Oh, okay, thanks.
Mm-hmm.
So these are the monochrome images?
Yeah, so this is, so Max had shown the kind of raw images and how he progresses from the individual exposures in a composite of combine of each exposure and each filter. So this is one of those combined images. This is the blue image through the B filter, and then the other one is the image through the I filter. And I'll just kind of blink between these. As you can see, the star, there's images of the stars are still in there a little bit, and you can see those move as Max was showing that they move between the exposures. So then we take those images through the different filters and reapply the color and end up with the final color composite. So any color that's anything in the comet or in the image that's different brightness between the two filters will show up as a different color. In this case, we applied a bluish green or cyan color to the blue filter and a red color to the I band filter. And so we have a range of kind of a narrow range of colors, and the comet actually inherently is not extremely strongly colored, but you do see this color change across the comet. So the coma, as expected, the coma is more blue or blue-green, and the tail is a bit redder. So you may have seen other images of a comet where people took images through three broadband filters. Is what people normally do when they're putting a visual image together. And in those images, the coma is strongly colored green. I think the emission that's coming there is, in fact, in the green or blue-green part of the spectrum, so that's kind of what you expect. But the filters that we use, since we don't actually have red, green, and blue filters that we use, the color kind of shifts a little bit towards the blue. But the color is real in that what's showing up as blue-green in the image really is a different color.
So what do you think's causing the colors, guys? Anybody?
That could be gas. Could be either the gas near in the coma of the comet, or it could be the size of the particles, dust particles in the coma.
Ah, cool. Okay, so one of the cool things about having the NASA come back online today is APOD is back up, and what's on the astronomy picture of the day today? Bonnie emailed us that earlier today. Bonnie, you want to show us?
Yeah, I have it up right now. I'm sharing it on my screen.
Okay.
This is the beautiful picture, and I mean, when you look at it, you notice two big things. Don't look at those two big things. One is the one in the middle, the
ignore
bright.
Those.
Yeah, ignore those.
Ignore the
two
big
things.
shiny stuff that's coming out at you.
Something about lighthouses.
Wow.
The thing in the bottom third of the screen that's blue is Regulus or Regulus. I don't know how you pronounce that star name.
Regulus.
Then above that is Mars. And above that, if you look teeny tiny in the upper 1/3, you can see Comet ISON.
Can you option plus that open a little bit more?
I can see. I'll put the full scale image in the
There,
hangout.
there it is.
There, can you see it?
There it is.
Okay.
Yeah. Well, now, what do we know about this picture? Who took it and with what?
Let me
It's
check.
by Pete Lawrence. And let's see, he took it with, I'm pulling this up here from APOD. So anyone that wants to look themselves, if you go apod.nasa.gov, you'll be able to see the newest astronomy picture of the day, and it's updated every day except for when our government doesn't work.
So, yeah, this was a fantastic image to come back with.
Oh, I know. It was yeah, I agree. This is and great timing for us, too.
Yes.
Awesome.
Has some of everybody's favorite things. I know a lot of people out there love Mars, and the comet is near and dear to all of us. So it's great to have it back and in this fantastic image.
Yeah, that's really nice. Really great.
So
go ahead.
did anybody mention why we see them together there? The comet is just now crossing the orbit of Mars, and it's not real close to Mars itself, but it's fairly close as we see it in the sky. I think it was about a degree away from Mars.
So what you're talking about is the alignment of Earth, Mars, and the comet are such that they appear really close together in the same night sky. You're not saying that ISON is right over Mars. In fact,
no,
that
it's not
already
real
happened.
close to it.
Yeah.
Although it's about the same distance from the sun now as Mars is.
Okay, so it's in between Mars and the sun, basically. Okay, well that's all. So one of the worries that we always hear about with Comet ISON is that Earth will pass where the comet was. It will pass, its orbit will pass through where Comet ISON had already been, and there was some worry that the debris or whatever it is left behind by the comet might cause us problems here on Earth. And Bonnie has found a paper that deals with why there will be no meteor showers from ISON.
Yes.
You want to talk about that a little bit?
Yeah, sure. There's a new paper by Saker and Asher, and this fantastic website called Astrobytes. It has a little synopsis of it today. So, I don't know, Scott, could you put that in the comments for people to find it? I just put it in our comment boxes.
Right now.
And so this has a beautiful little synopsis of this paper. Basically, what they did was they took the orbit of Comet ISON, and they mapped it out in the solar system versus where the Earth's orbit is. Then they took and calculated how far particles might fly away from ISON as it orbits, and looked to see if any of those particles would intersect Earth's path. What they found was, no, that's not going to happen. So we're not going to get any sort of meteor showers from Comet ISON. But they do. But they tried it with another comet, and they found that it's possible that we'll get some meteor showers from this other comet that you've probably never heard of. But still, meteor showers are beautiful. They're exciting. They're fun to go out. Go out with your friends, curl up under a blanket, and watch all night. So.
Yeah. Well, that's good. This is good to know though, because there have been a lot of people worried about what was going to happen when Earth went through this path of what Comet ISON was following, and now it looks like there's nothing to worry about there. So we can just have fun watching this thing go by in the night sky. Do we have any sense of is this going to be naked eye or not? Do we know?
That's always been the question, right?
Yeah.
Nobody wants to make a prediction. Come on, guys.
Yeah. All right. Well, even if it's not, it should still be something worth finding in binoculars. But I was just curious if, based on these latest observations, we knew something more about how bright it might be when it gets.
And for our viewers out there, there's enough public, star parties out there. Find your local astronomy group, and I'm sure they will be looking for it. So even if you don't have anything yourself, if it's not naked eye, you can go find a place that's local to you, and they will be more than happy to share their view of ISON with you.
Yeah. That's a good point. Use this as an impetus to get outside and look at the sky, figure out what's up there. There's all kinds of amazing things out there, and don't just sit here and look at computer images. It's wonderful to get out and look at the sky with your naked self, your naked eye self.
And not your naked self. It'll be cold. When
now don't
go out there with that Hubble hugger naked.
Yeah.
Warning for all the kids out there.
There's Hubble huggers out there. There's Hubble huggers out there.
Oh,
wow. Okay, so...
Reach a new low. That's right.
Okay, so I'm just looking at some of the comments here that Scott has been so kind to post on the chat box here. Make sure you guys all talk. This is from... Who is this from? It doesn't say. Oh, Chris WIXX. Make sure you guys all talk